Thank you, Lori. I appreciate everyone taking some time out of your schedule and sitting with us today. Um, I, 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 I AI is one of these new passions of mine. It's something that I think many of us are following. So I am just tickled to share my recent adventures in AI with you today, and specifically looking at how Fusion, AI and Fusion work together and how it's going to change really the future of the way we put things together and make things. Real quick agenda. I think Lori said, we're going to spend about 40 or 50 minutes here. So this is a rough idea. I'm going to give you a little introduction to AI and I'm going to share with you my recent activities in it. We'll talk about the different aspects of AI. But then we're going to focus on really the four main AI-driven tools that are currently being promoted in Fusion. That's generative design, automated modeling, automated toolpaths, and automated drawings. And as a bonus for today, I've got a new one to share with you. It's a new feature. It's not in the tool yet, but it should be coming soon. And by soon, I mean within a couple of weeks. There's going to be automated constraints in sketch mode, and I'm going to share that with you at the end of this. So a little bit about me before we get started. My name is Rusty Belcher, and many of you probably know me more from my support of Autodesk Inventor and specifically the factory design utilities, and maybe you've seen some of the other webinars I've done. That's my primary focus. I'm still on those tools for the majority of my time, but I do love jumping into Fusion when I get a chance, and it's amazing to see all the new things that are happening in that platform. And just I'm tickled to be able to share some of this stuff with you guys today. I am going to be talking about a few things that are outside of my area of expertise when we get into machining and toolpaths. That's really not my forte, but I want you to be assured that we have folks at Imagineit who are experts at that. So if you have questions on that, if I can't answer them, we can certainly put you in contact with somebody who can. So let's go ahead and talk about this AI thing. When you say AI, I think everyone just automatically assumes artificial intelligence. That's what that acronym stands for. But the more I dig into AI, I start to understand, or I start really to question, is that what AI stands for? So first off, artificial intelligence helps computers think, learn, and solve problems just like we do, only faster. And that's the main drive behind AI, taking over so many different industries. But looking at the acronym artificial intelligence, that's one thing AI can stand for, but it can stand for other things. How about augmented intelligence, adaptive intelligence, or for our conversation today, automated interactions, things that are automated. We've had many features inside of our CAD tools for years that are automated. That technically qualifies as AI, and we're going to talk about some of those features today. But moving on, you'll hear things like artificial imagination or artistic inspiration. I don't know, I'll share with you in a minute, but if you've ever done any of where you type in a prompt and something gives you a picture up on the screen, it kind of falls into that category. How about algorithmic intelligence? That's when you let the computer do all the math for you, right? You give it all the data, it does the math. We've done that before. That's what FEA is, and fluid flow, things like that. Artificial intuition or predictive insights. That's predictive analytics. And I did a webinar not long ago about FlexSim and process modeling and how that allows you to glimpse into the future and make better decisions. So eventually I'm going to run out of the AI acronyms, the ones that qualify. I did put up here machine learning, predictive insights. All of these things together, they work with and are representative of what AI means. I was following CES, the Consumer Electronics Show. And I don't know if you've seen it yet, but everyone's making a big deal about the Roomba. There's a Roomba that goes across and vacuums your floor, but it also picks up socks now and puts them in a basket. Everyone's talking about that. There's another AI called affectionate intelligence. And this is how AI is going to work in your home, how it loves you and wants to take care of you. So AI can stand for other things. But scientifically speaking, it's a branch of science that's focused on creating machines and software that are capable of performing tasks for us. These tasks usually or traditionally have required humans, but they don't have to now. But it includes abilities like learning from experience, recognizing patterns, solving problems, understanding language, and making decisions based upon input. We're not talking about the end of the world with the Terminator and all of that here. We're really talking about the weakest level of AI. Again, scientifically speaking, we're in this phase that's called the narrow AI, where our systems are designed for specific tasks, such as recommendations on algorithms, voice assistance, image recognition. You'll hear speech recognition in here as well. These systems excel in their particular tasks, but they don't really possess real or general intelligence. Now, general AI is still hypothetical. We haven't achieved that yet, but that is a system that would have human level intelligence and could understand, learn, and apply knowledge across various tasks. As I said, it doesn't exist yet, but it remains a long-term goal for the AI research. And then you have the super intelligent AI. That's the one everybody's afraid of. It's an advanced form of AI that would surpass human intelligence. And of course, it's theoretical, but its existence raises questions about safety and ethics that we'd have to address. But AI technology relies on methods, things like machine learning, deep learning, language recognition, and processing, using large amounts of data and algorithms to improve accuracy and efficiency on a given task. That's the AI we're here to talk about today. I wanted to share my recent adventures with AI, and I think I'm a general AI consumer. I think we've all gone up to ChatGPT and had great conversations there. I'll absolutely admit, I used ChatGPT to help me get some of the information we have in the presentation today. And I think, ChatGPT and those tools are kind of working their way into our daily lives, and they do make our lives a little easier. But I'm also using Meta AI. I'm a Facebook guy. I'm still on Facebook. And Meta AI is pretty cool. It does a lot of image generation. I use Luma for image generation. I went into my Adobe Reader the other day, and it had an image generator. So I've done those tools and others. And of course, here recently, for this webinar and for some other options or other presentations I've been working on, I've been working with the Fusion AI stuff, and I've been very, very impressed with it so far. Just again, with my recent activities, here's one of my favorite things I'm doing now. The image you see on the left, I'm going to flex a little bit here, so forgive me. I generated that image in Mechanical Desktop in the 90s, the knight and the chess pieces. It was for a website that I was doing some work for. That image took me 3 weeks, almost a month, to create and render. And then what I can do now through the Luma tool, I can just drop that image in there. And all I said was, hey, add some flair to this. And it gave me the image on the right in about a minute. It was scary how fast it gave me that. This idea of taking my design and enhancing it a little bit, I kind of throw that into this a new word for me, ideation. It's the process of generating, developing, and communicating ideas. It's a critical stage in the creative problem solving, specifically with innovation and design thinking, where individuals or teams brainstorm and explore potential solutions or concepts or strategies. So if you're not, if you're doing your designs and you're not taking advantage of some of these ideation tools that are out there, you certainly want to take a look at those. Here's another one. I'm going out there on a limb here, so you guys don't laugh too hard, but I was at the Commanders football game 2 weeks ago, the one they won in overtime on Sunday night. I was sitting in the parking lot, and I was just had my phone to entertain me, and I said, "Hey, imagine me breaking through the line, scoring the winning touchdown for the Commanders," and Meta AI drew that picture of me in the football helmet. It's not perfect, right? It's a cool image, and it's pretty neat, and I think neat is probably the right word. But there are problems with this image. There are problems with the previous image. You know, AI doesn't really understand how the chess pieces go on the chessboard exactly right. Or here, it doesn't understand that the number on the front of your shirt should match the number on the top or the side, or gosh, there's numbers all over this shirt. But it did what I asked it to do, and it was pretty cool. The image on the right, me and my wife have had a beagle for a long time. She just passed. And this year, during the holidays, I wanted a picture of me dressed up as Santa and holding a beagle. And I did that, and it worked out really well, except for a few things. I have 2 beards. If you look real close, there's 2 beards. And for some reason, AI thought I needed 5 fingers on one hand, which is weird. So I think it's kind of the state of AI right now. It's going to get better, but you still have to check into it or check after it. If you're asking it to do something, we still have to check after it and make sure it's doing it correctly. So I kind of want to steer the conversation more towards AI and Autodesk. And I still want to give you my recent adventures. I have to tell you guys, I am an AutoCAD old fart. I just am. I qualify for this card. I've been using these CAD tools since the early 90s. And I teach AutoCAD. I still teach AutoCAD. I love AutoCAD. It's a great tool. And as I teach it, I get these guys that come in that have been using it forever, and they say, you know, hey, I'm the guy who types every command in, and we're only ever going to use SHX fonts. You know, all that right mouse button stuff, we turn that off. It's just repeat last command. You know, we've all been using these tools for years, right? Forget the ribbon, bring the toolbars back. We're just used to using the tools that we have grown up with. But now we're confronted with a new way of doing things. And in a lot of cases, we become the barrier for progress. So this is my quote up on the right. I am an Autodesk old timer. So pardon me if I occasionally come across as a little suspicious of these newfangled AI ways of avoiding work, and get off my lawn, please. You have to recognize this is who you're talking to. This is who's presenting today. But I taught a class at AU this year about using really the factory design utilities in the construction cloud. And I wasn't expecting to get slapped in the face with AI as hard as I did. I took my factory design utilities, I laid out, you know, a factory floor with all the machines and everything in it. And I went up to the construction cloud and I uploaded that as part of a major construction project. And of course, you know, the construction project has the building. They're tracking that. They're tracking the wastewater sewage system, the freshwater system, the electrical infrastructure, all the fire suppression equipment, HVAC, and all of that goes into the building. And so they're collaborating with so many people. I'm just one of the collaborators. So I upload my data, and I notice that they take my data and they put it into a folder. That's all they do. And then they take the data from all the other collaborators and put it into a folder. That's it. They're done. They come back an hour later, and the tool has automatically run clash detection between all the files and even amongst the inners of the files itself. And it's come back with a report of potential clashes that you need to look into. I didn't ask it to do this. It just did it all automatically. That's the power of AI. I used to do this kind of stuff with Navisworks. I don't know if you know that tool, but in Navisworks would do this, but it would take about a week to figure out all the necessary combinations of things I needed to find clashes for. And here, this tool is doing it all by itself. And it reports back to me that, oh, the envelope of your robot is interfering with one of the structural columns of the building. It did that for me automatically. I didn't even have to ask for it. That's amazing. And that's what AI can bring to the table. So it's a big part of the future of manufacturing and construction, and we need to keep our eye on it. That's going to be the overall message for us during the upcoming bits of information. AI might not be perfect yet, but as designers and as people who use the software, we really need to focus on it and pay attention to it, because it is going to change the way we make things. So looking at Autodesk and AI, it's important to understand that Autodesk has been invested in AI for like over 10 years. They've been working with it and slowly bringing it into their systems. And now it's available in many of the platforms, including Fusion. So I want to take this moment here. This is one of our videos. I'm going to let Lori play the video and let one of the Autodesk experts, the guys that are in charge of how AI is integrated, tell you what they're doing.
AI is still at the infancy of its evolution. The AI we have today, 10 years from now, is going to look like a toy. So if you think of that, you go, oh my goodness, so what's going to happen over the next 10 years? I run our research organization that's specifically created to look 3 to 10 years into the future, both in terms of technology, but also in terms of our industries, to understand how technology and industry are going to come together to serve our customers in the world and all the products we make in different ways in the future. The current design and make industry is still stuck in so many of the old file-based, incompatible formats. Many industries still function in certain ways that require these older technologies. They're kind of a barrier to being able to go faster, to be able to be more reactive to your needs and to change quicker. A cloud platform would begin to resolve a bunch of these issues. You can imagine your bottom layer of what is a cloud platform is what we refer to as granularized data. It's how data gets decomposed into its atoms. What happens on top of that is once you've done that, it becomes much easier now to build flexible workflows such that every single person in your company who has got different work to do can have the right workflow at the right time and against just the right data. They don't have to be worried about what software they're running or what application. It's all kind of seamlessly flowing and it's interconnected. And it has to be an ecosystem. It has to be extensible because nobody can build all solutions to everybody. And we as Autodesk can't build every workflow for every one of our customers. Everybody's got different needs. And extensibility and customizability is so utterly critical. And you set the stage for creating an ecosystem where other producers can come and extend that platform. They can build customizations. They can buy customizations. AI is going to radically change the future of all of our industries and all of our customers. There are a lot of people in the world that have incredibly creative ideas to solve problems. Today, they have to use fairly complex software that is traditional software that is often not their forte. It's not something they're necessarily good at. With a lot of the new technologies, these technologies are becoming more and more accessible. AI is going to kick in. It's going to say, hey, don't worry, I've got you. I'm going to get all this data. I'm going to analyze it. I'm going to break it down to that one core insight, that one core signal that I think you need, and I'm going to give it to you. So you don't have to worry about spelunking around and trying to find it. We've got a bunch of very tough problems to solve in the world. And these are not problems that are going to be solved with sort of traditional mechanisms. This is going to require new kinds of technologies, new kinds of techniques. So what really excites me is I think it'll make certain professions, I think, a lot more accessible to more people. The greatest thing for me would be we see more people being able to use technology to solve more problems in the world. And tools and technologies that enable that would really make me feel that we've done our job.
All right, so I want you to understand that Autodesk isn't playing around with this. I'm an old timer. I start to look at this stuff and I see, it's a marketing campaign or it's a fad. It's going to come and go. I absolutely think that AI is here to stay and is here to change the way we work. There's a lot of benefits to AI. We're talking about improved efficiency, cost reduction, quality control, sustainability. At its core, we're talking about enhancing your human ingenuity. AI helps customers design and create more, allowing them to focus on strategic, creative, and high-impact work, and not the button smashing that we're all so used to. I want to move on into Autodesk AI and Fusion. And the rest of our presentation is going to focus on really the four main AI tools that are currently available in the platform. And I've got the fifth one coming. I'll mention that at the end. But specifically, that's generative design, automated modeling, automated toolpaths, and automated drawings. And, you know, if you're a CAM guy, you probably look over and see automated toolpaths and say, we've been doing that forever. Yeah, absolutely. But there's new iterations coming in that add AI for things like hole recognition or your steeps and, your steeps and shallows. So we'll take a look at those coming up. So generative design is our first stop. And I think many of us have seen generative design. It's been around for a couple of years now. Many of us look at it and say, hey, that's pretty cool, but I don't model parts that way. But for our conversation today, we want to talk about it because it really does lead into automated modeling. So this is another video we're going to watch. So I'm going to ask Lori to play that one for us, and let's let the experts tell us about generative design.
Generative design technology in Fusion enables rapid design exploration by simultaneously generating multiple solutions based on manufacturing constraints and product performance requirements. This design method starts by framing the most essential geometric aspects of the problem, adding, removing, or modifying to create preserved geometries where geometry must remain or obstacle areas to be avoided. Loads are applied to represent the rigors the part must withstand. And from there, multiple material options can be designated. Set the objectives, whether that be to maximize stiffness or achieve a certain factor of safety. And at that point, you're just about ready to start generating results. But before you do that, we'll deviate from traditional design scope to also include manufacturing constraints. Will the part be milled? Do you have access to a 5-axis machine, or 3, or 2.5? Could the part be produced on a water jet or plasma cutter? What about die casting? Or do additive techniques provide the best value in performance? All of these options come with unique benefits, challenges, and costs. In traditional CAD, teams often find themselves investigating one concept at a time. However, generative design in Fusion allows for simultaneous exploration of multiple manufacturing-ready designs tailored to specific engineering needs. After generating, explore the results with different tools and plots to compare each outcome based on the properties that are most important to you. The generated output is a seamless, solid model that you can modify and ultimately leverage all the tools found throughout Fusion's other workspaces. Fusion connects generative design and engineering with a fully integrated manufacturing workspace for those generating machine code and producing parts. This means you can start programming in the same environment and can even get a head start while the design is finalized, because the process to update the toolpaths is as simple as regenerating them. Fusion integrates generative design technology and accessible manufacturing options so you can bring optimized solutions into your business today.
All right, so generative design, I'll tell you right now, when we're talking about AI and we get to generative design, it's something we can't run through in a webinar like this. A typical general design session could take 2 to 12 to 10 hours or a couple of days to go through completely. So we've got to talk about it in an abstract form. But our next tool is kind of a derivative of that technology. It's called automated modeling. And this is something we absolutely can utilize. Anyone can do this. So I'm going to hop over here to Fusion and we'll talk about it. Here's an automated model that I generated. I go over here and I'm going to hide the main body here so we can hide that. I'm going to turn on a separate body so we can give it a little bit more to think about. But automated modeling takes that technology behind generative design and it puts it up front so that you can use it to really, I'm going to mention that ideation again. You can start to ideate and see what are some of the options available for the part that you need. So it's available on the main toolbar. You can click this And it's simple. You just go ahead and select the faces that you want to connect, and you select the bodies to avoid. You simply, after you do that, you click your Generate Shape button, and this is where that AI takes over. It's going to analyze the scenarios, and it's going to come up with, I think, 6 or so alternatives for your initial design. So it's kind of like we're jump starting that whole generative step. We want to see the outcomes very quickly. We can determine early on what we think our base part would want to look like. We're still going to have to take it all the way through the process of putting the loads on it, testing it. But this helps us get started. It just throws a few ideas out there and lets you pick from what you think is your favorite one. It's getting there. You can see they're coming through. They're getting pretty close. We'll let the first one, give it a little bit more time to take a look at it. But there you go. All right, I'm just going to jump on to, oh, there's the first one right here. So the first one, if I preview that a little bit, it's a little too beefy for me. This one's pretty good. That part right there looks pretty good. The X, that works for me too. I like this one though. I like the trusses it automatically put in there. I think I like that. I can thin that up a little bit. I think that looks a little bit better. I could check the other ones, but I can settle on this one. I can click OK, and I've taken that first step in generating that design. And it put AI down at my level. All right, I'm a designer. I'm a CAD guy. It let me use the technology to take my first step. And I've generated some other parts like this. Again, I can go through the generative process where they'll talk about how we're going to manufacture this. This might not be what the final part looks like, but it at least gives me ideas for what I could model to span the distance between these two components. It speeds the process up by putting those ideas in my head early on. And it's a great example of how AI is going to change the potential way that we design and work. All right, I wish, again, I could spend all day in each of these little applications, but we want to move on. We want to talk about automated toolpaths. So automated toolpaths is something that many of us have been doing for years. I can remember people actually generating G-code manually where they would write the programs up. I remember that. I never did it myself, but I remember people doing it. Now, I mean, we've let the computer handle that stuff for years. We give it the model, it generates the toolpath based on maybe it's machine learning in the past or it's best practices that we've over time kind of honed. But we run into some problems if you ever have to share that information with others on your team. So AI is coming into this process as well. There's two specific features that are part of the automated toolpath: hole recognition and steeps and shallows. Let's talk about this for a second. So if you bear with me, I'm going to play a video just to give you something to look at. I'm going to play this one. So kind of bear with me here. I want to make sure there you go. So when it comes to machining, you guys understand it's all about minimizing waste and improving consistency. I mean, it takes a lot to machine these parts. This is no small step in the process. So manufacturing productivity, it can be increased with the use of automated programming tools like hole recognition and the steeps and shallows. Both of these features are kind of AI driven. Hole profiles can be detected and programmed automatically, automating decisions that would have been previously accomplished manually. On top of that, it doesn't matter who's doing the programming, the resulting output will always be the same. Toolpath operations like steeps and shallows are also driven by AI. These features automate the finishing of freeform surfaces, automatically detecting the surface slope and applying the optimal removal strategy. As your part grows in complexity, automatic collision avoidance can be It can provide the control you need to machine your parts, utilizing the full 5-axis capabilities of your machines. You can also utilize probing. Probing allows you to align your stock material prior to machining. Parts can be verified while they're still on the machine, allowing you to detect variations and apply the remedies necessary before removing to the next operation. Manufacturing knowledge and best practices can be stored as templates and shared with the entire manufacturing department. This helps less experienced members of the team become more productive quicker, and it improves programming consistency across your organization. And if your design department is also utilizing Fusion 360, the integrated design and manufacturing environment ensures that programmers are automatically notified of new versions, allowing toolpaths to be quickly regenerated for the new design, and ensuring that the latest version of the design is always being used. Again, trusting toolpaths is something we have been letting the software do for quite a while, and the generation of those toolpaths is getting easier and more consistent to produce based on some of the new AI features that are part of the Fusion application. The next thing I want to focus on is automated drawings. Autodesk Fusion has allowed us to take that tedious task of producing drawings and lump it all into a single button click. Now, again, I was a bit standoffish when I first heard about this. Like, really? You're just going to let the tool do the drawings for you? But this is a game-changing feature, and it does exactly what it sounds like. It saves you significant time by automating those tedious steps for producing your drawings. I'll put a little timeout now. The image of the robot at the drafting board is something I generated with one of those ideation prompts I mentioned earlier. Worked out pretty good. But let's hop back over to Fusion for a second. And I've got to change my project here, so bear with me. I want to come down to my automatic drawings. And I'm going to jump into this chassis. We can close out the pins there. We don't need to see those now. So I've got this chassis jig, multiple parts all coming together. So I have an assembly of parts, and I need to do my drawings. So we're ready? We'd go up here, we'd come down to drawings from the design. In the dialog, we choose automatic. We want to do our full assembly. We want to select our template. I've got a template set up here with an ISO view on each sheet, and I want to go to all levels. Now I can click OK and just let the software generate the drawing for me. It submits the job, it starts, and you can see in my lower left-hand corner, it's working on it right now. Now, for time's sake, I already generated the drawing, so we can hop over and take a quick look at it. I'm kind of reminded of those images I showed you earlier where I had 5 fingers, or the numbers on my jersey didn't match on the shoulder pads and all of that, where it did it, and I have to go back and check, but still it did it, and the options are pretty good. It made my cover sheet with the assembly and the bill of materials. It did all of that. If I had sub-assemblies, it would have done those as well. And when I come into a file, I have the automated or the automatic dimension schemes available. So I can come in and change the way I want to dimension it. If I want to use ordinate dimensions, all right, I could do that, or I could use my baseline dimensions. I have to go back and check on it, but it's all here. Every single piece is ready and done. And it's smart enough to do things like broken views, right? Simple one part per sheet, which is a little new for me. I'm used to putting all the parts on the same sheet, but it did a fantastic job of doing the work. And it, by the way, it's already finished with the actual one. If I were to open up that one's a little bit different. I'll just pull it open for a second and make one point. If I jump into one of the sub sheets, this one had I put an isometric view on the sheet, so it would have an ISO view for every component. But this is an eye-opener for me, all right? This is something that I really do think we all have to be aware of, that drawings are becoming automatic from our designs. That's a game changer that we all need to be paying attention to. So if you haven't looked at automatic drawings yet, you really should focus on this. All right, I need to jump back over to our PowerPoint, kind of getting close on our time here. I will say this, probably my favorite feature in Fusion right now is automated modeling and automated drawings. Those are really good, and it's really starting to shift my attention more towards the AI stuff and away from the traditional ways of modeling and working. When I was doing the investigation for this webinar, I came across a couple of places online that mentioned automated sketch constraints. And the more I dug into it, I realized this feature wasn't released yet. Autodesk had done some preliminary stuff and put it out there, but they haven't released it yet. And I contacted the folks at Autodesk, and the product manager for this particular feature said that I could share it with you. And he also said it is coming imminently. I can't promise the release date, so I can't do that. But you know, we've all, if you're an Inventor user or a Fusion user, you're used to sketching with constraints, and they are automatically applied as you draw. But we're all still individuals, and we tend to constrain differently. And with the constraints in our sketches, that determines how our parts perform in the future. Well, wouldn't it be nice to standardize how we constrain sketches? How do you handle symmetry? How do you handle your dimension scheme? Do you dimension from the left to the right? Do you dimension from middle out? How do you do it? Do you dimension from 0 all the time? All of those are possibilities. But this new tool is built into the sketch environment, and as you draw, at some point, you can go over and apply your automated constraints. This will be a new button, and just like the automated dimensions, you'll be able to choose different schemes for applying your constraints. Your sketch will update, and you're ready to go with a fully constrained sketch. This is a big deal because this is the first time in my life that I can almost assure you that we're all constraining. You know, everyone in the organization can be constraining the same way, and we're all producing parts that, you know, maximize the benefit, or maximize the functionality of the part going downstream. That's a big one, and I think that's going to play a big role in the future. So I would look for that feature in the next couple of weeks to be added. So I'm going to start wrapping up here. We've looked at Fusion. We've reviewed really I'm going to say that now the 5, I guess, main AI features that are in play when you're talking about Fusion. We looked at generative design. We saw how that functionality kind of bled or shared functionality with automated modeling. Focused on that. We looked at automated toolpaths, something that many of us are already familiar with. I hope automated drawings kind of intrigued you, that you might go in and look at that and test that stuff out for yourself. And we debuted that auto sketch constraint, or sketch auto constraint option, that'll be coming here soon. Autodesk is continuing to invest in these capabilities. This stuff's not going away. I mentioned, you know, the first couple of times I heard about AI, I absolutely was the AutoCAD old fart and saying it's a fad, or it's a marketing ploy. That stuff will never stick around. I mean, I remember virtual reality, all right, and all of that, and everyone was going to be working virtual with headsets and things like that, and it didn't happen. This is different. This is truly going to impact the way we do things. Look at ChatGPT. Once you realize what that tool can do, you're not just going to leave it sitting there for your competitors to use. You're going to use it and take advantage of it. once these tools become commonplace, everyone's going to be doing it. And you need to pay attention to the changing landscape of your manufacturing platforms. This stuff is going to impact us. It's not a matter of if it's going to impact you. It's a matter of when and potentially how far behind the curve you let yourself get. So pay attention, heads up, when somebody says something about AI in manufacturing, that should pique your interest and you'd want to follow along as to what's going on. I did borrow heavily on the presentation today, so I wanted to make sure I shared the links with you. Hopefully these links will be provided in the chat for you if you want to go back and review any of the videos that we talked about. There are other videos in here that I highlighted. There's extensive videos on the Toolpath integration. There's a website, the Autodesk AI website. You can get most of this information if you go to that site, that very first prompt, autodesk.com/solutions/autodesk-AI. That's basically the site I pulled most of the information for this presentation from. So of course, I want to thank the authors of that content. I want to give them all the credit for producing that content that we referenced during the presentation today. And of course, I want to thank them. I want to thank you for participating in this, making time for it. And of course, at this point, we can open it up to any questions you might have.